So hello everyone, in this video we will be discussing volume of solids of revolution by disks or washers and volume by slicing. So to recall, volume by disks, this method involves constructing a disk perpendicular to the axis of revolution. So let R sub 0, R sub O, and R sub I be the outer radius and inner radius of the disk respectively, and dW be the thickness of the disk. And let the interval AB be the interval in X or Y covered by the region or the height of the disk. So the volume can be expressed as the integral of pi, the outer radius squared, minus the inner radius squared multiplied by dW from A to B. So kung naaalala nyo, yung volume ng isang cylinder can be written as pi r squared h. So where h is the height of the disk. So in this problem, ito yung given by dW, which is equal to h. Then ito yung inner radius, then ito yung outer radius. So for volume of bislicing, consider the cross-section A of a solid. If A is perpendicular to the x-axis, then the volume can be written as the integral of A of x dx from A to B, where AB is the interval in the x-axis covered by the base of the solid. And if A is perpendicular to the y-axis, the volume can be expressed as the integral of A sub y dy. So this is supposed to be dy from C to D, where the interval CD is the interval in the y-axis covered by the base of the solid. So you can see the illustrations in the left. So i-consider nyo muna yung plane. So wag nyo muna isipin na 3D siya. So yung plane lang na tinutukoy, yung area ay yung area in red. So for the remarks, if A is perpendicular to the x-axis, we make use of vertical rectangles. So x-axis, vertical rectangles, and for the y-axis, horizontal rectangles. So for problem 1, let R be the region bounded by the square root of 8 minus x squared and bounded below by y is equal to square root of 2x and the x-axis. So set up and evaluate a definite integral equal to the volume of the solid generated by revolving R about the x-axis, and set up a definite integral equal to the volume of a solid whose base is the region R and whose cross-sections perpendicular to the x-axis are isosceles right triangles. So for problem 1.1, so dinivide natin yung region into two, which is R1 and R2. So R is equal to the sum of R1 plus R2. So for R1, the interval AB is, so ito yung magiging limits. So it is from -2, square root of 2 to 0. Then the outer radius, or R sub O, is equal to the square root of 8 minus x squared minus 0, or square the square root of 8 minus x squared, and the inner radius is equal to 0. So ito yun. So ito yung region of interest natin. So R1 muna. Yung outer radius natin ay ito. So itong nasa taas. Then yung inner radius ay itong nasa baba. So, or the x-axis. So for the inner radius, lagi siyang 0. So yung value ng y ay laging 0 sa inner radius. But for the outer radius, the value of the radius is a function of x, since nagbabago to. Since for this, kunwari, itong x na to, iba yung value ng r dito, and iba rin yung value ng r sa x na to. X na to. Ayan. So the volume of R1 can be written as the integral of pi the quantity square root of 8 minus x squared dx from -2 square root of 2 to 0. So as you remember, yung volume kanina ay by washers or this can be written as the integral from a to b pi outer radius squared minus inner radius squared dw or yes, dw. So the volume can be so the integrand can be simplified to this expression. So quantity 8 minus x squared na lang. Then solving for the integral, we get 32 pi square root of 2 all over 3 cubic units. So don't forget to write cubic units since volume yung sinosolve natin dito. So for R2 naman, AB is now equal to 0 to 2. So ito na yung region of area of interest natin. 0 to 2. Oops. So yun. The outer radius is now is the same. So square root of 8 minus x squared pa rin. So ito pa rin siya. But the inner radius is now square root of 2x minus 0, which is equal to square root of 2x. So ito na yung inner radius natin. So ito yung difference from R1 and R2. So since R1 ay ito and R2 ay ito. So hindi na siya nasa x-axis lang. And the volume of R2 is now equal to the integral of pi quantity, the quantity square root of 8 minus x squared minus the quantity square root of 2x squared dx from 0 to 2. So ito lang ay pi r naught squared minus r sub I squared dw or integral from a to b. So simplifying the integrand, we get this expression or this integral, and solving for the integral we get, so ito ay dapat x, so 8x minus x cubed all over 3 minus x squared from 0 to 2. So the answer would be 28 pi all over 3 cubic units. So ito ay para lang sa volume when R2 is revolved about the x-axis. So the volume for the entire region R is equal to the volume from R1 plus the volume from R2. So the final answer would be pi quantity 32 square root of 2 plus 28 all over 3 cubic units. So bago nyo pala makuha yung bago nyo ito ma-solve, syempre dapat alam nyo kung paano i-draw yung region bounded by these expressions. So for example, for this problem, alam natin na yung square root of 8 minus x squared ay hemisphere. So kunwari ito yung x and y axis, and this is y is equal to square root of 8 minus x squared, and for y is equal to square root of 2x, so yung itsura niya ay maging ganyan. So y is equal to square root of 2x, and the x-axis ay itong nasa baba. So yung bounded ng tatlong region na yan ay itong region na to. Ayan. So kaya naging ganito yung figure natin. So for problem 1.2, set up a definite integral equal to the volume of a solid whose base is R and whose cross-sections perpendicular to the x-axis are isosceles right triangles. So yung difference lang nito ay sa volume by slicing, yung usual yung ginagamit ay rectangular strips. Pero yung ginamit dito ay isosceles triangles, right triangles. So since the cross-sections are perpendicular to the x-axis, we will set up a definite integral in terms of, ito dapat ay x, in terms of x. So let R1, R2 be the same regions from problem 1.1. So for R1, ito siya. Yung kanina, R1, itong kalahati. So the base is equal to the height. So since base is equal to height, since for an isosceles right triangle, equal yung base and height. Also, yung magiging governing equation pala natin or formula ay yung kanina, which is if galing sa x siya, in terms of x, a of x dx. So, ang difference lang nito kapag gumamit ka ng rectangular strips ay yung area na kukunin mo ay for the area of the rectangle. Pero kapag gumamit ka naman ng triangular strips, yung kukunin mong area ay for the area of the triangle, the right triangle. So the area for R1 is now equal to quantity 8. The quantity is square root of 8 minus x squared all over 2. Since recall that for the area of a right triangle, it is given by 1/2 base times height. Where ito yung base, ito yung height. Ayan. So VR1 is now equal to this integral. Then for R2 naman, equal din yung base and height. Pero equal na siya to the square root of 8 minus x squared minus the square root of 2x. So ito yung base kasi na kinukuha natin. Ito. So equal siya sa itong hemisphere minus the value nitong square root of 2x. Y is equal to square root of 2x. Y is equal to square root of 2x. Then y is equal to 8 minus x squared. So the area is now given by this expression. And the volume is given by this integral. So yung volume ng buong region is equal to the sum of the volume when R1 and R2 are revolved about the x-axis. So the volume, which is now equal to the integral of 8 minus x squared all over 2 dx from -2 square root of 2 to 0 plus the integral of the quantity square root of 8 minus x squared minus the square root of 2x squared all over 2 dx from 0 to 2. So that's it for this lecture.